Okay, hello. I don't know if anyone's with me live tonight or not, but if you are, welcome. This is our last live stream slash lecture for the semester. Um, Hi, Kevin K. Nice to see you. I'm glad you're here. Anyway, this is it. This is the last lecture for the semester. Of course, everyone hopefully has seen by the time you're watching this, but I sat down and got all of the projects graded on Monday. So you should have seen your project fours, and I've got a few demos to show you from some of your classmates' work. So this last week is we do have the typical routine of homework, lab, discussion. Some of you may know mathematically that this last week's work doesn't matter to you or not. If in doubt, I would say do the work, but some of you may already know. So anyway, I'm offering you this content as a way to bridge you, to help you bridge the gap between the Go language that we have used this semester and the C++ language that if you're continuing on to the second semester class, you will probably encounter next semester, or whenever you take the second semester programming class, it's likely it will be in C++. So yeah, I'll do a complete solution for the lab here on the live stream slash lecture for you to use as you choose for this last week of work. So let me do, yeah, let's do demos first. Having trouble getting the thing. There we go. I'll demo some of your classmates' work first. Just so you can see what those look like. Maybe make sure you're still seeing what I see. You do. Okay. So I'll just go very quickly. So just some things. This one's cool because this person actually created and is presenting counters on both sides. These are just counters. It can be done as part of a struct. It can be done as just integer variables. You've all done counters in the class. The other thing I like about this project is that the person was kind to the evaluator and made it easy to buy out an item. So one of the things you can sort of keep in mind going forward is that if someone has to sit down and work with your code and your application, you can help yourself out by helping them out, by making it easy for them to find what they're looking for. And making it as easy as possible for whoever evaluates your coding effort to test. So I wanted to be able to test selling things out. So there's the counters there. If you look at apple juice, I bought one. There's one left. You bought one of them. There are 0 left. You bought 2 of them. I will try to buy another one. This is one of the sort of just tests that I did because in the requirements it says you need to handle sold out items. So this is the way to do that, right? Don't bother your user saying I want 0 of a sold out item. Just says you can't have that item. I'll buy a couple more. So a few more, I will finish shopping. So this person decided to handle payment just like normal money. So I owe 13 bucks. So the way I would test that is I would only give them 12. And this person did a good job of handling the payment sequence because they give me credit for the 12 that I paid already. I'm going to go ahead and pay 99 cents. Still owe 1 cent. So why don't I pay like a buck? 99. Simple math to do in programming, but it makes for a good quality application. So good job on that one. Here's another. And I just picked some that like worked really well or occasionally did something kind of in. So this person also made it relatively easy for me to buy out an item. So I'll keep buying. Now it's down to 3. I'll keep buying. 2. I'll keep buying. 1. I'll keep buying. Try to buy it again. Nope. So, and then I'll buy one something else and then I'll check out. So here again, I'll pay $13. Okay, so I still owe 95 cents. I'll pay $1. I should get a nickel back. There's my receipt with the amount of it that I bought and the total amount of the quantity computed together. How much I owed, how much I paid in total, which was a very nice touch. So good job on that. This one had good layout, so this person took the time to get a neat little layout going. So notice here that Skittles is set at 1, which means that the evaluator, me in this case, can very quickly buy it out and then test to see if they're handling things that get sold out properly, which they are. So I will go ahead and 0 is a product number to leave. So there's my receipt, looks really great. Grand total, so I'll pay this time. I'm pretty sure, but I'll just pay. There's my change, and then I'm done. So anyway, nicely presented, nicely done output. Okay, so here's another one where this person also just presented the counters for how much you've purchased as you shop. This person made it a little bit harder to buy things out because the lowest one was at 10. But fortunately, the interface is very easy. So there's not extra press enter to continue kind of stuff. It's just go. Let's see if this one handled. Yeah, so this one handled the sold out. Okay. 0 to exit and pay. There's how much I bought. 10 purchase at $2.50 for a total of 25, exactly as the requirement said. Let's go 24. Still owe $1, so I'll just pay $1.01. Should get a penny back, and the program's done. Nice job. Yep, this person was also sensitive to the evaluator. Press enter to return. All right, so 6 out of stock. So you can see how that went. I'll buy a couple of other things, and then I'll check out. There's my total. I'll go ahead and just pay $62. And there is my receipt. Nice, clean, straightforward. Has all the required information on it. This wasn't a difficult project, even for a first semester programmer, unless you waited till the last second, and then maybe it was difficult. But what I would recommend, though, if you're watching this and you didn't get your best result, there's good programming practice in this project. So if you want to get better, this is a good place to do it because you practice with structs, you practice with methods, you have to manage counters, integer counters, and you have to do calculations, and you have to do formatted output. You have to do loops and decisions. Everything from the whole semester is actually in this project. It's a great place to practice. I sometimes will write this project when I'm trying to learn a new language. Anyway, I'll buy a few things. Oops. Oh, I got to put money in the machine. So this person handled it like a machine as opposed to paying at the end. This person wants you to put in money, and I just put in a whole bunch so that I can just go shopping away. Sold out as expected. So anyway, and then my receipt showed me my grand total, showed me the change. So this person collected the payment up front as if I were feeding a machine and then buying stuff out of it and then getting change, which was perfectly fine. It worked out quite well for this person. So nice work. It was very nice work. Okay, so there's the project 4 demos. And again, if you didn't get the desired result, if you are in our line of work, you do want to be able to use programming as one of your tools that you can express your solutions to problems in, that you can express your ideas in, since in computer science we use computers to solve problems. So getting better at it is worthwhile. And you don't need someone to tell you you have to. Just I recycle my own projects for my own learning purposes sometimes, just because I know I can kind of exercise the basics around a new language, let's say. All right, so let's go walk through this week's module, and then I'll do the lab so you can see how that's done. So the whole point this week is to expose you to C++, because that is the programming language that you will likely be using in your second semester programming class for those of you who are going on. I believe that it is very easy to move back and forth between Go and C++. C++ is a uglier syntax. It's got more punctuation symbols in its syntax and more parentheses and garbage on the screen than you have to look at in Go. So Go is a very nice looking programming language as far as programming languages go. C++ is not. But they're not that far apart. And the way we'll experience that is by implementing last week's lab this week, but in a different language. And I'll show you the whole process going through it. So the goal is to expose you to C++, to show you that you can use Replit to create C++ projects, which means that if you are looking to get yourself warmed up and continue practicing, you can use Replit for a variety of different languages. I'll have you do some reading to identify the sort of the core features of the C++ language as a way of getting introduced to it. You'll translate a Go program into C++. You're going to watch me do that here on the live stream. And then also do a little bit of comparing and contrasting C++ and Go, which we've started that conversation in last week's discussion, I think. So anyway, what I believe is that you should not find C++ syntax intimidating when you first move over into programming and algorithms 2, if you're going that direction, until you get to the stuff that everybody finds intimidating, which is pointers. You have a basic introduction to pointers through the Go language. C++ has an uglier syntax for pointers than Go does, but it does use the same concept. Okay, so a couple of readings, and of course, as always, the questions on the homework assignment this week are based on those readings. And again, some of you may choose just to use your free drops. So remember, the lowest 2 scores of your homework, labs, and discussions all get automatically dropped, which is why I'm not big on giving people deadline extensions, is because I have already dropped literally 2 full weeks of your work for you. But if you've been doing the work conscientiously all semester, then you might avail yourself of that this week. Maybe just watch what I do and then leave it at that. Many of you probably have the room to not have to do this week's work if you don't want to. But if you do, I will evaluate it and get you scores back. And I think that you will find the experience useful, especially if you are going on to the second semester class. So homework, as always, based on those 2 readings. We have a lab, which I guess I need to get those prepared so I can copy the code over. So let me pop that one open. So it's got a shop. It has a little bit different file name on it, but the same concept as we did last week, with the same functions, just written in a different programming language. And I'm going to do that here in a moment. One last discussion, which is really just to say something nice. We'll all just kind of collectively share best wishes amongst ourselves and go on. So if you do that, if you participate in the discussion, you get the 100 points like you do every week if you participate. But you don't have to do any research. I'm just asking you to say something nice to everybody. And then finally, reminders. So just so you know, this is a normal week for us. Homework, lab, discussion, the usual routine, because Project 4 is now in our past. Okay, I'm going to switch views, and hopefully I didn't break anything, because I want to do some side-by-side stuff. Okay, it is still working. Thank goodness. So what you see on the right-hand side there is the Go code from week 16, last week's lab. Let me get it to where I can actually reach it. And on the left side is a C++ REPL. you simply, when you're creating a REPL for C++, when you click create, just choose C++ and then name it accordingly. Now, I'm not going to do that because I already set one up. But anyway, so I just want to show you what it looks and feels like to do the same program, exactly the same program, but in C++ instead of Go. So we will start with the shop code, and then you're not going to see me switch the views, but I'm going to go grab shop.h from this week's lab. So I need to show the side view. I need to create shop. Oops, I'm all caps. Shop.h. So this is C++ and the extensions are different. I'm not going to bother you with what the .h means. What it stands for is headers, but don't worry about that. It's shop.h, not shop.go. Yeah, so Shamar is asking, how did I get this C++ REPL? And like I just showed, when you go to create, you pick C++, you name it, and now you have a C++ language setup. Okay, so that's what I did in advance of the class, is I made a C++ REPL, which is one of the choices at REPL. All right, so now I have a file shop.h. Why? Because the lab told me to create and populate a file called shop.h with some stuff. So here's the stuff. I'm going to try, actually I can make it fit by turning that off. So it's the same program as last week. It's exactly the same program, but written in C++. Okay, so I'm just going to go through it, and we will look at the differences between Go and C++. I have the Go version on the left, so it's just there for your reference. And we will do the C++ version here. So there are some C++ things. So you can see, for example, this note that says pragma once on it. Let me get that over here. I'm trying to figure out where to put this so I can kind of see what I'm doing. Just scooch that over a bit. Okay, so this pragma once is a C++ thing, and the C++ kind of compiler and execution tools, they're just a little bit different. So this is the thing that's a little bit different. All of this junk up here is covered by the import fumpt. It's not entirely true, but in the Go language, you don't have to do nearly as much work to gain access to sort of all the basic parts, what we call the standard libraries. So Go has the things that I am including here, which is the C++ include is akin to the Go language import. These are the various libraries that I need to do the same task in C++. So I actually need more libraries in C++ to do the same work that I'm doing in Go with only the fumpt import. Yeah, so there's that. Some general things I would say about these two languages while we're starting to dig into this code, and I have them on my agenda notes as well. They are both general purpose languages. And what that means is that they are not designed with any particular kind of problem in mind. They are programming languages that can be used to do anything in software that people do. Make games, do graphical user interfaces, like make a web browser, make a text editor, make the vending machine program. They're both capable of doing all of those things. Now, it is true that people discover that they like C++ better for some kinds of things, and some people like Go better for some other kinds of things. But for all intents and purposes, they can both be used to do any and all of the same kinds of things because they're both general purpose languages. C++ is object-oriented, and you're going to get a taste of that here. And I would challenge you to make note of if there's a dramatic difference between C++, which is considered object-oriented, and Go, which some people think is not. I would argue that you're going to see the code looks pretty close to exactly the same. They are both compiled languages, and what that means is that you you have to have your source code processed into a program, an executable, to actually execute it. So most of you only experience that in Replit by clicking the run button. But clicking the run button causes your source code to be processed in C++ and in Go, and then it will execute the resultant, what we call the binary, the executable program. Let's see. So they're both compiled. C++ is considered to be better when speed and efficiency are required in your software, when you're doing like heavy kinds of processing work. But C++ syntax is also a lot more complicated than Go. There's a lot more semicolons, there's a lot more brackets and parentheses and all kinds of extra symbols that you don't have to deal with nearly as much in the Go language. Go, I would argue, is sort of generally not used when the most speed and efficiency is required. So you could say in that way it's slower, but it's also much simpler to look at. I mean, so you'll be able to compare that in what I do tonight and in this week's lab, just to see, like you can just see already at the top, the include statements in C++ have a pound sign in front of them. They have the alligators on either side. And there's a lot more of them to gain access to the same kinds of functionality that I only need a single import in the Go language. And that's by design. There's a downside to that. In the Go language, it chooses, it kind of has to automatically bring in a bunch of extra stuff, which makes it less efficient. Whereas C++, because I have to list specifically only those specific items that I want, arguably C++ is more efficient that way, because it's not just sort of gathering up all of the potential things I might want to use in my program and only giving me what I specifically asked for. Whereas on the Go side, I'm getting functionality kind of included that I may or may not be using. Okay, so here we go. We are going to then do a C++ struct that will be similar to the Go language struct. They both call them structs. There is a little syntax difference in C++, which you will see a lot. At the end of the struct, there's a semicolon. Okay. So what does it look like then to have a description, which is a string? So that's how you make the struct field in C++ called description. So you can see it's on line 6 on the Go code on the right. So in Go, the data type comes second. And also Go doesn't require the semicolon there to mark the end of that thing. So C++ puts the data type first. Not a big deal. Let's see, we need a quantity, which is an integer. So data type first in C++, semicolon in C++, but still pretty similar, right? Price per item, which is a float. So there you go. There is the C++ struct item, which looks almost exactly like the Go one with just those small differences. So I show you this and ask you to go through the exercise because I want you to know and I want you to feel that C++ is not that big a deal. It's not a big deal to move from one language to another when the languages are so similar. You'll find this, by the way, if you look at other programming languages. Python will have similar constructs, although it's a little bit weird in terms of the way it formats itself. Java, very similar. JavaScript, very similar. The C language, very similar. The D language, very similar. Rust, up to a point, is pretty similar. So once you've got one of these languages, we call them C-like languages because they all have a lot in common with the C language itself. You'll find that moving between C languages is not too tough. You just kind of have to learn what the major differences are so that you can contend with those. Anyway, so there's the item struct. No big deal. Here we come on shopping list. So shopping list is different because in C++, something like the shopping list, and I'll fold it so you can see this, the shopping list is completely self-contained. So in the Go language on the right, let me get access to it. It's over here. In the Go language on the right, we have the struct shopping list, and then we have a whole bunch of methods for shopping lists that follow, right? So all of that stuff is the shopping list code, but in Go, the struct is separate from the builder function, which is separate from the method, which is separate from the method. And the way Go ties these bits and pieces together, for example, in the methods, is it has what's called, what is this thing called? The target, or whatever it's called in Go. So this is how we know that add item is a shopping list function, is because it has this receiver. That's what they call them, receiver. So this one is also a shopping list function. So Go has all these pieces separated out from each other in code, but with receivers kind of tying them back together. So in C++, what we do is we actually embed all of the shopping list code inside of what we call a block in C++. Same in Go, but inside of this class shopping list. So inside the class, you will find in this section labeled private, the label and the all items. In C++, we don't have slices, but we do have vectors, and they are very similar. So this vector of item is akin to, I need to put it back where I can see it better. This string label and vector of item called all items, that's what is going on in line 12 and 13 in the Go code. So the data type comes first, label, which is a string, and then we have all items, which is a vector of item, which is in the Go language we would create as a slice, the empty square brackets of item. So again, really not that huge a difference. Not that huge a difference. Okay, so now let's go through the different functions. So we have on the right, new shopping list with a label. That's what this does. And I would argue in this case that C++ is actually a little bit simpler. This creating a shopping list function, which is called new shopping list in Go, which is called shopping list in C++. It's embedded inside the class. Which means that there's a little bit less syntax around it. So in the Go language, we have func new shopping list, label string, and then star shopping list, and then the bracket. So in C++, this particular function is actually a little bit less complicated. You're going to see one weird thing here. Yeah. And this is one of the more difficult things to understand in the C++ version of this code. This is the receiver. So one thing that C++ makes harder than Go is that in Go, you can easily find the receiver. For example, if you look at add item, the receiver is the shopping list labeled S. In C++, the receiver is referred to as this. And it's hard to explain, which is one of the reasons why it's hard to understand. It is a reference to the self. So we'll see it when I do the driver part, but whichever shopping list is involved right now is this shopping list. In C++, we literally call it this. But when you're coding it, you can't tell what this is. This is the receiver. In the Go code on line 17, it's the ampersand shopping list. That's what this is referring to. Literally this, THIS with the arrow, is referring to the same thing that ampersand shopping list is referring to. So there, that's that whole thing. There's the label getting attached to a shopping list. All right, so let's go on to add item, which starts on line 20 in the Go code on the right. So here's add item. Notice that this code is a little bit simpler on the C++ side because we don't have to code the receiver like we do in the Go code, where we have S star shopping list. That's the receiver. The receiver on the C++ side is the magical keyword this. So what are we supposed to do? Oh, we're supposed to do a if statement here. So same code. So where it says if s dot has item, so this has item I. So what's the differences then? This, which is weird in the object-oriented C++ code, it's s dot on the Go side of had item. Anyway, has item, same call, and you'll notice then the extra parentheses. So C++ requires parentheses around the logic, whereas the Go code does not. Go has tried to kind of strip off the extra syntax to be easier to read. But C++ been around a long time. It's got more complexity. So if this has item, then instead of s dot, we'll say this increase quantity I semicolon. So Go doesn't require these semicolons after the statements. C++ does. But there again, this little arrow replacing s dot, the receiver of the call. And then we have an else. So notice though that the if else, other than the extra parentheses, is exactly as we'd write it in Go, just has the extra overhead on it. And then we'll say this all items. So instead of say equals append all items I, we say push back in C++. That achieves the same work as the Go code, where it says s dot all items equals append. So this all items push back is how we append to a C++ vector. But again, just notice how very similar the two pieces of code are. Some parts of the C++ code, the object-oriented C++ code, are a little bit simplified. They have less stuff going on. And in other places, it's a little bit more dense syntactically, right? The extra parentheses on the if statement, the extra semicolons on the action statements. There is add item. Let's do has item. So how do we do that same has item, which starts on line 28 on the Go side? So for very similar. And in fact, you might look at this and think to yourself that this is actually less complicated on the C++ side. But basically, we are ranging through the items one item at a time. It just, that's the range loop on line 29 on the Go side. And then we say if the parentheses, because it's C++, item, which is I dot description. Oops, I better not call it I, because we already had an I, which was the case in the Go code, was it not? Yeah. Oh, we called it little item here. Let's call it IT though. So IT, which is the loop item that's already in the collection, is equivalent to the target item's description. Still, you see how similar they are. Then we return true. Statements in C++ need a semicolon at the end, and then we go down here and we say, if we'd never returned true and get this far in the function, then we failed return false. There's actually no extra lines of code in C++. It's the same amount of code with a little bit of extra and a tiny bit of different syntax. All right, let me roll up a little bit on this side. So increase item quantity comes next. So we will increase item quantity. It's going to be the same. So we're going to loop through the items. In C++, we have a slightly more efficient way of solving this problem, where we don't need the counting loop with the J on it. So that little ampersand on line 74, in C++, that little ampersand appears in different places and means different things at different times. So this is one of those things that later in the semester in a C++ course you will get to and talk about in greater depth. But this ampersand means that I have the ability to actually update the item. If I took the ampersand out, I would not update the item. And you may remember when we talked about methods and those little stars, that if we took the star out, we can't actually make changes to things. So this is the C++ version of that. If I took the ampersand out, I can't make changes to things. If I put the ampersand in, I can. All right, so I'll loop through all the items. If that item's description is the same as the description of the item I'm trying to update the count on, then I will, oh yeah, increase, so dot quantity. There we go, same thing. So the gymnastics I had to do in the code on the Go side, like on line 40, I can avoid in C++ because C++ has a nice little efficient syntax for I need to update this thing. But anyway, it's the same amount of code. And in this case, I would argue that the ampersand is confusing, but the rest of the code seems a little bit easier to track. It's a little bit less complicated. So there's that one. Let's do toString next. This is one where C++ is going to look different. C++, the way it does output is different from Go. So that's one of the early things that you'll get in the second semester is how do I do outputs in C++. I'm going to show you in the driver in a second. So instead of fumped printf and fumped sprintf, so this is like the fumped sprintf, getting a string of stuff. So let's see, I got the label, and then I need to, so you can see that that line 93 is the same, means the same in C++ as the code on line 48 on the Go side, on the right side. All right, so now let's do some ranging. Parentheses. So C++ uses lots of parentheses. So here around the logic of the Go. So I think I can just get the items. Yeah, I can. So output, we don't do plus equals on the C++ side for doing this kind of thing. We use, it's called the insertion operator. Some people call them the alligators. And then we will get what? We need the, it's going to be kind of nasty, actually. Let's see. We need the, oh, we need a number. How do I want to do that? Yeah, we'll do it in the Go style just so you can see that here. So, okay, yeah, well, let's do that. So then you can see what C++ requires when we need the index value. So we need the index, the 0, 1, 2, 3, 4, 5, all the way up to the end of the collection. So in C++, this is how we would do that. In the Go language, we're using a range loop and capturing the I. In C++, we don't have that option, so we have to use the loop to produce the I. Anyway, we want what here, an I plus 1. Close the parenthesis, put a space. We need the description. Oops. That's going to make life miserable. Well, that's just too bad. We need this items you've seen this syntax before. That's how we access individual elements of a slice. Same idea works in C++. Get the description, and then I'll just keep going. What comes after the description? A comma and a space, and then the quantity. And then a space at space $, and then we will get the price per item, which is going to fall off. Yep. Oh, that's a bummer. Each. New line. Yep, that's most of it. That's not actually all of it. I got to add a thing. So anyway, this is the first time in this little project that C++ has made life harder. It doesn't have... C++ does have a printf, by the way, but that's kind of considered the old school way of doing it. So I have done it in the more modern way. So the more modern way of doing this, building up this output in C++, is more dense syntactically. There's a lot more symbols and stuff going on with all these alligators, and then with all the pieces kind of inserted. And then I still have one little problem I got to solve. So let me go show you how to solve it. Let's see. I should have loaded this up before. Give me a second. I'll go grab it real quick. Let's see. Where is it? Yeah, here it is. All right, here we go. Make sure that you're still seeing things. All right, so you are accustomed in the Go language to being able to do this %.2f. And one of the reasons why I'm doing this in sort of the modern C++ way is because I hope that you will come away thinking that was awesome. I didn't always like it, but it's way better than what I'm about to do. So here's... here is the same thing in C++. So there's the C++ version of %.2f. There's the 0.2 part, 2 places after the decimal. And then fixed and show point just guarantee that the dot always shows. Even if the value were like 1, it's still going to show 1 point and then 0, 0 after it. So that's the C++ version, the modern C++ version of %.2f in our Go code to the side. So that function is particularly unpleasant to do. It's the worst one by far, and I've left it on the screen for a good long while. I hope it all shows it does. Um, so there's some nastiness in there. Anyway, there's an example where the Go language has things to offer kind of just built in that are much more elegant. So there's a question in chat if I have to do fixed and show point. I think that you can probably get away without show point, but I often see people doing all three of these things. So it's possible you don't have to do show point, but it doesn't hurt to go ahead and just sort of out of paranoia do both to make sure that you get 4.00 or whatever it is. But I think you're right, Shamar, that I believe show point might be optional, but I don't risk it. So there you go. There's to string. And then last one is total cost. So what's that going to look like in the C++ language? Well, we will say float cost. In C++, you have to zero things out manually. So on the Go code on line 50, what? 57 says var cost float 64. In Go, variables are automatically zero. In C++, they're not. And that can screw up calculations badly. So in C++, when you need something to be zero, you have to make it be zero right from the start. C++ will not zero that for you, which I think is actually better in Go that it does. Not in C++ though. If you don't make this zero, you may get a bad result. All right, now we will range over the items in C++. I do think that this is pretty elegant. We will say cost plus equals I dot quantity times I dot price per item. In C++, if one of those two things is already a float, then the whole thing becomes a float. You don't have to floatify things. So you might think that this is a convenience that C++ will just kind of promote integers to floats. If there's a float anywhere in the mix, which price per item is, then the whole thing becomes a float without any help. But I like that Go forces you to be explicit about this. I like that Go forces you to specify that you want the things coming out to be floats or integers. Can you overwrite that? Can you override that behavior? You can. So if I wanted it to be, so in Go it says you've got one of each you got to pick. In C++, so in Go, well, I won't do it in Go, but we can. The C++ code for this would look like this. So that's float 64 of that quantity in C++. Static cast thing. And of course, if you wanted it to be all integers, you could do the same thing instead to this side. Which is kind of hard to look at. I'll hit enter so you can kind of see it all. So that's what intifying something in C++ would look like, as opposed to just int in parentheses. C++ has this more elaborate syntax. But because I know C++'s behavior is that if there's one float, then everybody's a float automatically. Then I'll go ahead and just let it be. And then at the end, we return the cost. So not more code, just slightly different code. That's what the shop part looks like on the C++ side. And then down here at the bottom on line 122, I'll show you where the other end of that is. This is actually the end of this entire container called class shopping list. So this is where that started. And I can tell that because I can click this little arrow and fold it. And everything that I just did fits in between those two places. So that's the way that C++ in some ways makes the syntax simpler by bundling the methods inside of the thing as opposed to having to list them separately. Yeah, it's kind of cool, isn't it, Shamar, that you can do that. It's very helpful for big pieces of code. All right, so there's the whole thing. Before I shut down tonight, I'll go back and I will slowly go across the screen. So let's now go look at the other part of this thing, which is the driver, main.cpp as opposed to main.go. Collapse that, and let me get the lab code for it. Okay, so here's the lab code, the driver part for C++. So one thing you'll note here on the C++ side, let me switch over on Go. Go, there we go. Let me get main.go. Oh wait, I already had it. All right, so there's kind of a minimal example of what's going on the Go side. So one thing you'll notice, Go doesn't need to be told to import shop.go. And the reason why that's so on the Go side is because if you're in the same directory and you are also in the same package, so here's shop's package, which is main, and main's package, which is also main, then automatically you can access things between the two files. On the C++ side, we actually have to manually encode connect the shop code in. So this include of shop.h is how we get access to the code we just wrote in here. Here is basically the C++ import fumpt. This IO stream thing is how we do inputs and outputs in C++. Fumpt is how we do inputs and outputs in Go. And then you have this little extra piece of syntax, which is related to the way C++ organizes its libraries. So the Go language, its standard libraries are much cleaner to look at. So if you need strings, you just import strings. If you need time, you import time. Whereas in C++, you have to import the thing and then also sometimes have this what's called a using directive to be able to use it. Okay, so let's look at the C++ code for doing things like how do we create a shopping list. So the way we do it in C++, what did I call it over there? Oh, Boyd's Groceries. All right, so there's the C++ version of what's going on in the Go code on line 8. So you may remember it. We wrote a little thing. I said that the new function inside of the C++ class was called shopping list. So that's what that is doing there, is creating, oh, I called it my list. Let's call it my list so it matches exactly. That's the C++ version of what's going on line 8 in the Go code. 2, display the shopping list instance. So where we have fumpt.printf %v mylist in C++, we will say cout mylist.toString endl. Endl in C++ is an end line. You can also represent it as simply the new line character, but I thought I'd make sure that you'd seen that end line marker. That's a line break, ENDL, end of line. So the Go code on line 9, more or less, is what's going on here on line 2 in C++. Create an item instance. Item, I'll call it, I guess I'll call it, no, I'm going to call it item 1. And then in C++, the way we populate this thing, apples, 3 of them, 75 cents a pop. So there is in C++ how we achieve what's going on line 11 in the Go code. Very similar, right? They're not that dramatically different. C++ likes to put what kind of thing it is first. And then we don't have the colon equals thing in C++, just the regular assignment operator. And then pretty close to the same syntax for setting up the data for it. Okay. Number 4, add the item. So my list dot add item 1. Darn near exactly the same except for the semicolon. And then you'll notice that I'm doing things in lowercase letters in C++. That is a difference in my C++ style versus my Go style. If any of you are taking a class with Luke Sathram, he will do his C++ will look like a lot more like my Go. So Luke's C++ style is closer to my Go style, and my C++ style is a little bit different than my Go style. Anyway, there's line 4. That's what we're doing on line 13. We'll do the same thing here again. My list dot to string. I haven't tried to run it, so I'm just kind of taking a flyer. It's all going to work. So that's line 14 in Go. I'm just printing out the information about it on number 5 there. Add the item instance again. This time should cause, yep. So we'll try it again. My list dot add item 1. Same thing that we're doing on line 16. Display it again. So you notice how we're just sort of mirroring the exact sequence that we had going on basically on the Go side of things. What's number 8? Oh, now it's going to have us do more than we did on the Go side. So I'll do it on the Go side too, just for fun. Create a second item instance. All right, so list item 2 equals, and then I'll do I don't know, oranges. We'll just get, I don't know how many of those we'll get. Let's get 10 of them, and let's assume that they're like 99 cents a piece. I don't know how much oranges cost. So there's another item created in the same way that we created item 1 above. We will add it to the list. So my list dot add item 2. So hopefully though you're kind of at least seeing like this isn't that much different. It's not like crazy amounts of different going on here. There's extra syntax, the semicolons as an example. The outputs are quite a bit different in C++, so that takes a little bit of practice, but most of it is very similar. Add an item, create a third item instance. Item 3, that's to get the practice. Let's put some, got apples and oranges. I'm going to get milk this time. Or I'll get a bread. Bread, just get 1 loaf of bread, and I'll assume that it's like $3.50. Add it to the shopping list. And then one last display to see if everything looks like it should before we call it quits. This return 0 is different in C++. So at the bottom of the main function, that is here, right? It's func main. In Go, it's int main. In C++. So this int part on main is why at the bottom it does a return 0, which is an integer. This int main is a way that we signal error codes in the C++ language, but we won't have any error codes to deal with here. So I haven't run it. I may have made mistakes, but we'll find out and we will fix them, and then we'll go review the code one last time. I'll probably share the repo so that you can, I mean, I'd rather you type it, but it is the last semester. Oh, increase item quantity. I misspelled something. On line 50 of shop.h, I misspelled something. Line 50. Yeah, increase item quantity. I'll go back and review this code. All right, let's see if it runs. Yeah, so you will have seen something similar to this, although slightly more simplified. Anyway, there's my empty grocery list first. There's my having added apples. There I am actually um, adding the quantity of apples all over again. So it was 3. I tried to add 3 more. I got 6. And then I added 10 oranges, 1 loaf of bread. And notice how the prices are all formatted like we'd expect them to be. So yeah, there's my application. So I am, and I just hope no one takes me up on the offer, but I'll go ahead and share the whole repo as an act of hopefully wanted kindness. So you'll have a link to this original repo so you can see the code as I wrote it, so that if you are doing the lab, you can get it exactly right. And the thing I want you to do, of course, is just to kind of look at compare the two, so that if you are planning to move on to the second semester, or you're planning in some way to experience C++, what I want you to do is have the confidence that it's not that much different. There are a few things that you'll have to get used to, mostly like the outputs, and the extra semicolons, the extra parentheses on loops and if statements, but many similarities. And I just did the exact same lab with pretty much the exact same results as we did last week in our Go class, so that you could see and compare as we did that. Okay, so I'm not going to go back and review the code because I'm going to put a link to the REPL to share with you on the lecture page. So if you are doing the lab, you will find the completed solution that you can then borrow from for your own. I hope that you'll take the time maybe to type some of it, or at least study over it as you're doing that, especially if you need to kind of start preparing yourself for working in C++. I prefer Go. I think it's an elegant language. I think stripping away some of that extra garbage in the syntax is much desired. I very much like fumped printf and fumped sprintf. Those are my personal impressions. You can and probably will develop your own if you go on to the second semester class. What else do I got? That's it. I ported Lab 16 from the Go language to C++. So Kevin K is asking about Carbon. I have looked at Carbon. I haven't used it yet, but Carbon is on. It's a little bit deeper down my list right now. But yeah, Carbon is getting some interest from people. I have been working lately in OCaml because OCaml is dramatically different because it is a different style of programming, a different paradigm. So I'm into functional programming and sort of my own learning right now, which means that my language set is very different. It's F# and Erlang and Elixir and OCaml and Gleam and a variety of languages that are not C-like at all in most cases. Anyway, try it out though, Kevin K. If you've tried it or if you're thinking of trying it, it has caught people's attention. So it may or may not be one that gets more adoption, but I would definitely look into it. I'm going to look into it at some point because I have been reading about it. Yeah, so cool. So Shamar asked if I keep the Twitch videos up. So I'm not at a level as a streamer on Twitch to get any more. I think I get 30 days or 60 days. So I will leave the Twitch videos up as long as they don't die, basically. At some point, Twitch times them out and takes them down on me because I don't pay them and I'm not at a high enough tier to get that service for free from them. I will leave the YouTube versions up for a while, probably 6 months or so, maybe a year. Thank you, Shamar. I appreciate that. Yeah, so the YouTube ones will be up there for longer than the Twitch ones because YouTube won't force me to take them down. At some point, I'll take them down just because I have a project on the side that I may start building up new content. I also might just make myself a new channel. Anyway, yeah, so YouTube will be up longer. Twitch is, I think, maybe 30 days, maybe 60 days, I forget, before they take them down, take them away from me. Okay, anyway, I'll just sit here for a moment, see if there's questions. I got done early. I will be sharing the link to the REPL, so you don't have to worry about getting it off the screen. It will be linked to the lecture page. Thanks for the good work. I wish you the best of luck. This is, I don't know if you guys knew it, but this is the last lecture I will ever do in my life as a teacher. So I'm retiring on Saturday, basically. So thanks for being here for that. I wish you the best of luck with whatever comes for you next. Thank you, Shamar. Appreciate it. So take care. I'm going to sign off, and that will be it.